Hello and welcome. Today we're going to be doing an example of a first order linear differential equation. So let's write down the differential equation we're going to do. dy dt plus cosine t times y equals cosine of t. Alright, so with this equation we can clearly see that it's linear. This is our Ly is equal to cosine t, and it's clearly a linear operator. And we can write this out a little bit. A little bit differently. Where that's the operator L of y, and that's of course equal to cosine of t. So we want to find. So again, the goal always is to find a y of t, and our method is essentially find a factor, a rho of t, that we multiply to enable an integration. So let's do that now. Okay, clearly what we see here is that P of t is going to be cosine of t, and Q of t, that's this part right here, is also cosine of t. All right, so as usual, that would imply then, I'm going to kind of make a little space here to do this. Well, let's go to another page actually. Okay, so it's going to be dy dt plus cosine t times y equals cosine t. All right, so again, that means P of t is equal to cosine. And Q of t is equal to cosine of t. All right, and that means then that rho of t is going to be equal to e to the antiderivative of P of t dt, as usual, which is e to the antiderivative of cosine dt, which is, of course, e to the sine of t. Okay, great. Now we multiply by both sides. So we have y prime, and that's what I'll just call our dy dt, e to the sine of t, plus cosine of t, e to the sine of t times y is equal to cosine of t, e to the sine of t. All right, so this looks like the result of a product rule. In fact, we can rewrite this whole thing as the derivative of the product y times e to the sine t. And that, of course, is equal to cosine of t, e to the sine t. Now we take an integral of both sides. We take the antiderivative of both sides. And clearly we get y of t times e to the sine of t is equal to this integral here. So clearly we see that substitution is order. If I take u is equal to sine of t, that means that du is equal to cosine of t dt, in which case that becomes e to the u du, which is equal to e to the sine t all plus c. And then finally, we solve for y of t, which is going to be equal to, it's going to be equal to 1 plus c e to the negative sine t. And that's our solution to our problem. Okay, and that again is by dividing out by e to the sine t to solve for y of t by itself. Okay, so of course that is a general solution. And in order to find a particular solution, we simply have to apply some sort of initial condition. But I'll leave it at that. So that, of course, is a thorough solution to this particular first-order differential equation. Thank you very much.